Today we're going to start looking at exponential functions. We're going to graph exponential functions. We're going to be able to identify exponential growth and decay. We're going to answer questions involving exponential growth or decay. We're going to know the approximate value of the natural number e and understand how the natural number e is used. And we're going to answer questions about continuous growth. So an important definition, an asymptote is just a line that the graph comes closer and closer to but never actually reaches. The other important definition is an exponential function is any function that is in the form of y is equal to a times b to the quantity of x minus h plus k, where b is bigger than 0 but does not equal 1. Alright, so we do know that h and k normally are vertex in a lot of these equations. They also tell us how far left and right we shift with h. And it also tells us how far up or down we shift with k. And a is still going to be our stretch or our shrink factor as far as vertical goes. Alright. All of these functions have a parent function of y equals b to the x, and if we know what our graph of the parent function looks like, it's pretty easy to graph all of the other functions. If we don't know what parent functions look like, well, we're going to need to make a t-chart to graph the functions, which honestly kind of sucks. How does each of the different parts affect the graph? Kind of just went over that, but go over it again. Remember that everything on the inside of the function, and the exponent in this case, moves the graph left and right, and everything on the outside of the function moves the graph up and down. Also remember that addition and subtraction in the function just causes the graph to move, while multiplication, a in this case, causes the graph to be stretched, aka we're going to multiply our y values by the a number. We also should have noticed that all of the graphs that we're going to take a look at got closer and closer to y equals 0. Those graphs have an asymptote y equals 0, and every exponential function has an asymptote, and it'll always start at y equals 0. But if there's a number added to the end of the function, aka k, the asymptote is just going to go to y equals k. We can now start problem 1.